Now let's say the first question. It says determine the binomial distribution for which mean is equal to, mean is, let's say we denote mean by small m, is equal to twice variance, variance is this, and mean plus variance is equal to 3. So equating these two, we can put it here like this: 2 sigma square plus sigma square is 3. This implies sigma square is 1, that is variance is 1. And from here what we get, mean is 2 sigma square, 2. So we get mean and we get variance. Now from binomial distribution we know that mean is equal to n into p. P is the probability, n is the number of trials, and variance, where is it, variance, this is equal to npq. These are well known formula. So let's put it here. np, we have m, mean is np, n into p, so np is 2, so 2q. From here we get 2q, and mu square is, sorry, sigma square is 1. So from here what we get, q is equal to 0.5. Obviously, because q is 0.5, p will be 0.5. We can put it here to get, we have the value of mean is 2. We have to find n, probability is 0.5, that is 2. So n is equal to 4. Now we have n, we have p, we have q. Now we can have the probability distribution. Clear? I am rubbing it. Sigma square is equal to 1, mean is equal to 2, n is 4, and p is equal to q equal to 0.5. I have written this. So what is binomial distribution? It is q plus p to the power n. That is, in this case, this is our binomial distribution. So for r equal to 0, our probability will be n is 4. So 4c0, p is 0.5 to the power q, that is 4. Clear? Sorry, to the power r is 0, into q, 0.5 into n minus r. So this is 4, this is the first value. We'll calculate it. Similarly, r equal to 1, so this is 4c1, 0.5 to the power 1, 0.5 to the power 3. This is very easy for us because we'll have only 0.5 to the power 4 in all our distribution, because both p and q, p and q are equal, therefore it becomes easy. This is 4c2, 0.5, 2 and 2, so this is 4. So everywhere we'll be having 4, and r equal to 3. 4c3, 0.54, and finally r equal to 4. 4c4, 4. Clear? So 4c0, what is 4c0? This is this, 4. So this is 1. So 4c0 is 1, and then we have 1 to the power 4. That is 1 by 16. This is 4c1, 4 factorial 1 factorial 3. This is 4. See, this is 4 factorial 3. So this is 4 into 1 by 16. 4 into 1 by 16. For uniformity, let's write it like this. Then factorial 4 to 2. 4 into 3. This cut. Then 4, this cut. So 2, 3 is 6. So 6 into, this will be 6 by 16. Now this one, 4c3. So factorial 4, factorial 3, 1. And then 1 by 16. So this is 4 into 1 by 16. So the answer will be 4 by 16. Okay. And finally, we have 4c4. 4c4 is 1. Why? Factorial 4, factorial 4, factorial 0. This will be 1. So this is 1 by 16. So now we have the whole binomial distribution. For r equal to 0, this is this. R equal to 1, this is this. So we have our binomial distribution. If you want, you can write it like this. Properly, you can write it like this. R 0, 1, 2, 3, 4. This is first is 0 is 1 by 16. 1 is 4 by 16. This is 6 by 16. This is 4 by 16. Finally 1 by 16. So this is our binomial distribution. Okay. Next, the question is find P for x less than equal to 3, that is up to this point. What we do? This is equal to P1 plus P2 plus not P1, P0 plus P1 plus P2 plus P3 up to this P3. So this is 1 plus 4 plus 6 plus 4, 10, 4, 15, that is 15 by 16. This is our answer. Clear? We have two more questions on binomial distribution. This is the third one and this is the fourth. Why I have written the fourth one to this side? Because of space constraints. So let's see question number 3. It says if 1 in 10 machines is faulty, find the probability that out of 5 machines at least 4 are working. Now this is a very simple question. The only thing is you have to give, you have to keep your focus on this. 1 in 10. So the probability 1 by 10 is for faulty machines. It says the question is asking how many are working. That is, it is asking about Q. So for ourselves, probability is we have to find P. So probability for our sake, the probability is 1 in 10 machines are faulty. So how many machines are working? 9 by 10. So our probability is this, because we have to find this thing. Or you can go by that side also. That's not a very difficult thing, but just to keep in mind, probability is this. Now it says out of 5 machines, at least 4 machines are working. That is, we have to find Px greater than equal to 4. That is P4 and P5. We have to find these two values. What is P4? 5C4. Probability is 9 by 10 to the power 4. 1 by 10 to the power 1. Then P5, 5C5. 9 by 10 to the power 5, and this to the power 0, that is gone. So what is this? We can find the value, calculate it. I am also doing it. This comes to 91854 by 10, 10 to the power 5, so 5 zeros. 1, 2, 3, 4, 5. So here what is the probability? This is 0.91854. This is the probability. You understood what I said? You can go reverse also. Probability can be 1 by 10. Then in that case, you'll have to find it says at least 4 are working. That is, the probability that you will get will be for faulty. So you can 1 minus that much will be equal. That is 1 minus P0, P1, P2, P3. In that case, that will be equal to this only. Clear? So this is our question. Now this is a question on binomial distribution. It says fit a binomial distribution for the following data. What do we need to know for binomial distribution? What is binomial distribution? It is simply Q plus P to the power n. So we need to know n, we need to know Q, we need to know P. N we know, this is 5. So n is 5. That is known. We need to know either P or Q so that the value is available. Then our probability distribution will be there. Let's see. What is total frequency? See, 14 plus 2, 16, and this. So if you add this all, sigma f is equal to 100. Clear? What will be mean? Mean, that is given as NP. We know this. That is n is 5, so 5p is equal to Mean, how do we get mean? This into this plus this into this by 100. So this will be 0 plus 14 plus 40 plus 102 plus 88 plus 40 by 100. What is this? Say 88 and 100 to 190, 230, 230 and 42, 70 and 42, 84. So this is 284 by 100. That is 2.84. So our probability will be 2.84 by 5. What is it? See the value? So it is 2.84 by 5. 0.568. Therefore Q is 0.432. So we have our distribution. What it will be? I am rubbing this. So our distribution is Q plus P, that is 0.432 plus 0.568 to the power 5. So this is our binomial distribution. We have to fit it in this table. Let's see. For r equal to 0, this will be, this is Q, this is P. So we have Q to the power n, that is 5. So this is 0.432 to the power 5. For r equal to 1, we have 5C1, Q, P is 0.568 to the power 1 into 0.432 to the power 4. Then for r equal to 2, we have 5C2, 0.568 to 0.432 to the power 3. R equal to 3, we have 5C3, 0.5683, 0.432, 2. So if you calculate it, this is the value that we get. If you multiply it with sigma f, you will get frequency. Sigma f is 100. So multiplying it by 100, it is 1.50. This is 9.89. This is 26, almost 26. This is 34. This is 22.5. And this is about 6. Okay. So now we can make the binomial distribution like this. First is 1.5. For r equal to 1, it is 9.89. Let's say this is about 10. This is 26. This is 34. This is 22.5. And finally this is 6. So this is our frequency after doing binomial distribution. Okay.